It's 2:46 p.m., March 11th, 2011. The ground beneath Japan begins to scream. It's not just a shake, it's a magnitude 9.0 earthquake, the fourth most powerful ever recorded in the history of seismology.
And at the Fukushima Daiichi nuclear power plant, the systems actually did exactly what they were designed to do. The sensors tripped. The control rods shot into the reactor cores. The nuclear fission stopped. By all engineering accounts, the plant survived the violent shaking.
But 50 minutes later, the real threat arrived. A wall of water, black and churning, 14 meters high. It slammed into a seawall that was only 10 meters high. And in that moment, history changed.
We've all seen the footage, we know the outcome, but the question we are asking today is uncomfortable. Was this an act of God, a natural disaster so massive that no human could have predicted it? Or was it a failure of imagination?
Today, we are tearing apart the autopsy of the Fukushima disaster. We're going to look at why the lights went out, why the pumps stopped, and why a Japanese government report concluded that this was, unequivocally, a man-made disaster.
Let's start with the geography. To understand why this happened, we actually have to travel back in time to the 1960s, long before the first atom was split at this site. It starts with the dirt.
The dirt?
The dirt. The construction phase. The Fukushima Daiichi site is located on a bluff overlooking the Pacific Ocean. Originally, nature had built a fortress there. The bluff was about 75 meters above sea level.
35 meters is huge. That's over 100 feet. If you build a nuclear plant at that height, a tsunami is simply not going to touch you. It's a natural defense system.
Exactly. But TEPCO, the Tokyo Electric Power Company, looked at that 35-meter bluff and saw a problem, not a solution. They needed to put the heavy reactor buildings on solid bedrock to make them earthquake resistant. But the bedrock was deep underground. Plus, nuclear plants need a lot of water for cooling. The higher up you are, the more money it costs to pump that seawater up.
I think I see where this is going. They chose efficiency over elevation.
Drastically so. They made a choice to slice the top of the mountain off. They excavated 25 million cubic meters of soil and lowered the station's ground level from 35 meters down to just 10 meters above sea level.
That is staggering. They literally dug their own grave. They took a plant that would have been completely immune to the massive 2011 tsunami and placed it right in the splash zone to save on construction and pumping costs.
And they built a seawall, sure, but they designed it for a tsunami of about 5.7 meters. They looked at historical data and decided that was good enough.
Good enough is a terrifying phrase when you're dealing with radiation. But let's fast forward to the day of the disaster. The wave hits. It's 14 meters high. The ground is 10 meters high. The site floods. But help me understand the mechanics here. Why does getting the basement wet cause a nuclear meltdown? These are sealed reactors.
They are sealed, but think of a nuclear reactor like a tea kettle that never stops boiling, even after you turn the stove off. When the earthquake hit, the reactors shut down. That stops the fission process. But the fuel is still incredibly hot from decay heat. You have to keep circulating water over it to keep it cool. If the water stops moving, the fuel melts.
And to move water, you need pumps, and pumps need electricity.
Precisely. The earthquake had already destroyed the power lines coming from the outside grid. The plant was on its own. This is a standard emergency scenario. This is why they have backup emergency diesel generators. These are huge truck-sized engines designed to keep the lights on and the pumps running.
And where did they put these life-saving generators?
In the basement.
The basement of a building right next to the ocean.
Specifically, the basements of the turbine buildings. When the tsunami overtopped the seawall, it didn't just splash the buildings, it drowned them. The water rushed down into the basements, instantly destroying the diesel generators and, critically, the electrical switchgear.
So the grid is down, the backup generators are underwater. What about batteries?
Most of the DC batteries were also located in flood-prone areas. They were swamped. This is what engineers call a station blackout. No AC power, no DC power. The control room went dark. The operators couldn't even see the water levels in the reactor. They were flying blind in a melting plane.
It seems like such a basic oversight. Design 101. Don't put your emergency electrical gear in a hole if you live near the sea. Was this standard practice?
It was for the General Electric Mark Y reactor design, which originated in the U.S. In the U.S., putting things in the basement is fine because tornadoes are a bigger threat than tsunamis in many places, but Japan is tsunami central. They imported a design without adapting it enough to the local environment.
This brings us to the controversy. TEPCO and the government initially tried to say this was Sote Gai, outside the scope of assumption. Basically, nobody could have predicted a tsunami this big.
But that's simply not true, and this is where the man-made verdict really comes from.
Tell me about the warnings.
In 2008, 3 years before the disaster, TEPCO's own in-house simulations showed that a tsunami as high as 15.7 meters could hit the plant if a massive earthquake struck off the coast.
15.7 meters? That's almost exactly what happened. They had the number?
They had the number, but TEPCO executives buried the report. They argued it was too hypothetical. They worried that building a higher seawall would be too expensive and, ironically, would signal to the public that the plant wasn't currently safe. They were afraid of a PR nightmare.
So they chose PR and profit over safety?
That is essentially the conclusion of the NAIIC, the Nuclear Accident Independent Investigation Commission. In 2012, they released a scathing report. The chairman famously wrote, "It was a profoundly man-made disaster that could and should have been foreseen and prevented."
That is a heavy indictment.
They blamed regulatory capture. Basically, the regulators and the industry were too cozy. The regulators weren't policing the industry, they were protecting it. They ignored geological evidence of ancient tsunamis. They ignored the modern simulations.
It's interesting you mentioned the regulators and the unforeseeable nature of the event. Because there was another nuclear plant nearby, right? The Onagawa plant.
Yes, the Onagawa nuclear power plant. It was actually closer to the epicenter of the earthquake than Fukushima. It was hit by a larger, higher tsunami. And do you know what happened?
What?
Nothing. It survived. In fact, the gym at the Onagawa plant served as a shelter for the local townspeople who lost their homes. It was the safest place in the region.
That is an incredible contrast. Why? What was the difference?
Elevation and culture. The engineer who sited Onagawa insisted on keeping the plant high up, 14.8 meters above sea level, specifically because he studied historical tsunamis. He fought for that height. And he was right. It proves that Fukushima wasn't a failure of nuclear technology per se. It was a failure of where they put it and how they protected it.
So we have the flood, the blackout, and the ignored warnings. But we have to talk about the explosions. Because when people think of Fukushima, they think of those buildings blowing up. If the reactor shut down, why did it explode?
That wasn't a nuclear explosion. It was hydrogen. This goes back to the design flaws. As the fuel melted, the zirconium cladding on the fuel rods reacted with the steam. That chemical reaction creates hydrogen gas.
And that gas needs to go somewhere.
Right? In the containment design they used, the pressure built up. They needed to vent it to the outside air to save the containment vessel. But because they had no power, they couldn't open the valves. It was a catch-22. By the time they managed to manually force them open, which was a suicide mission in itself, hydrogen had leaked into the upper service floor of the reactor building.
And then, a spark?
Exactly. Boom. The roofs of Unit 1, 3, and 4 were blown off. This released the radioactive plume that forced the evacuation of 150,000 people. If they had passive autocatalytic recombiners, devices that eat up hydrogen, or filtered venting systems, which were already standard in some European plants, the explosions might not have happened.
It's just layer after layer of missed opportunities. Not upgrading to modern safety standards. Ignoring data. Cutting costs on excavation.
It really is. It's a tragic reminder that in high-stakes engineering, you cannot design for the likely scenario. You have to design for the nightmare scenario.
So, to answer our opening question, was it nature or was it us?
It seems like nature provided the test, but human decision-making failed the exam. The tsunami was the trigger, but the loaded gun was the decision to lower the hill. The loaded gun was putting generators in the basement. The loaded gun was ignoring the 2008 report.
TEPCO has since built a massive new seawall and moved generators up high. They've learned the hard way. But for the people of Fukushima, For the land that is still recovering, it's 15 years too late.
It forces us to ask a difficult question about the future. As we look at climate change and the increasing frequency of extreme weather, are our current infrastructures, our dams, our grids, our chemical plants ready for the unforeseeable? Or are we just waiting for the next 2008 report to be ignored?
That's the thought we're going to leave you with today. It's not just about nuclear power. It's about the systems we trust to keep us safe.
Thanks for listening to this deep dive.
We'll see you next time.